the future's still human driven. I think there's going to be a realization, especially with a lot of companies who think like agentic AI and all this stuff is going to solve every problem in the world. I think those people are probably going to be sorely disappointed.
Hello and welcome back to another episode of InstaBlinks. I'm your host, Brian Graf, and today we have David Fontana, who is an AI ML engineer at NetApp with me. David, welcome to the show.
Yep. Hey, Brian, thanks for having me.
Hey, we're really excited about this episode today. There's a lot to cover. We will see how much we can get through in the time that we have, but we want to talk all things AI. So basically, let's level set. We've all heard the terms AI for like decades, but over the last few years, that's really, I feel like, accelerated a lot, and we're starting to hear a lot of other terms that I'm hoping, David, you can help kind of debunk or at least unpack for us of what they mean. So, maybe starting with Gen AI, which I feel like is kind of the big one that everybody talks about, or at least they think that they're talking about, and what that is compared to some of these other ones that we'll mention here shortly.
Yeah, definitely. So Gen AI, like people use that term frequently, and it's kind of this weird catch-all bucket for everything AI. When in reality, there's different classifications and different buckets that your AI solutions can kind of fall into. So Gen AI or generative AI, the way I kind of like to think about it is it's basically an AI system where it generates, right? You give it a prompt, and it generates a result, whether that's text, image, video. So it's something that an AI system that generates something. Typically these days, like Gen AI, like the definition of like what people really kind of like, the parallel to it is it's basically your LLM these days. It's you give it a prompt, it generates something, and that's kind of done. And the other term that you typically hear quite frequently is RAG, so retrieval-augmented generation. So that's another term where you kind of take an LLM, so an existing large language model, and you want to augment it with a certain knowledge set to make it kind of like a domain or knowledge expert. So you want to train it in like medical, or you want to train it in legal related topics. And so that's basically imparting knowledge or augmenting an LLM with that kind of knowledge. And the last one you hear, which especially right now, because it's the hot thing, is agentic AI. And these systems are really kind of where you're turning over the keys to the thought process for like a large language model to be able to make its own decisions, to formulate a plan of attack to answering a user's question, and then having that chain of thought or that multi-step process to like, I need to do research, here are the tools that I can access, and then out on the other end, you get your answer for the user. And so like those are the three different buckets that I kind of like to look at when you're trying to classify like these AI solutions.
Yeah, so I think when we talk about Gen AI, you've got like MidJourneys, you've got, I mean, even I think MidJourney is a great one because you're basically prompting it and it's creating a visual for you, right? But Gen AI also covers other things like text, right? So reports, creating content based off of my son, for example, asked me to ask Grok to have it tell us a story, right? Create a story about Star Wars and tell it to us. So would that be a pretty good Gen AI example right there?
Yeah, definitely. So usually it's, something is being generated based on a user's request, and it's more taking the initial context and without the reasoning mechanism, although the lines are getting blurred a little bit there, generating something, whether it's video, a story, or some other output for the user. Yeah.
Okay. And so then I guess the next, you talked about RAG for a moment there, and that feels kind of like a dot subversion of AI where you go and you take something that potentially was already generated, or you're adding in content. If I wanted to scan a bunch of books and have it come back and tell me, or let's say prescription papers, and say, hey, can you tell me a summary of what these different prescriptions do, or are there any adverse reactions between these? That's more of RAG, where it's working off of a pre-trained model, but I'm also adding additional context in for it to work off of, correct?
Yes, yeah, definitely. So, like, another way to kind of think about it is like if you were to give an LLM who hasn't been trained in any kind of like medical knowledge or legal advice or legal expertise, and you were asked to, ask like Llama 2, Llama 3, any kind of medical related stuff, yes, the LLM might have been trained on some medical information, but it's highly doubtful that large language model has been trained on very specific details to like medicine and drugs interactions and that kind of thing. And so that's the reason why when you ask it like hyper specific or hyper focused question, like an LLM hyper focused or hyper specific questions, you tend to get hallucinations or plausible answers that might seem correct. But if you aren't in that field, you'll be, oh, that totally sounds reasonable. But in reality, it's really kind of just hallucinating an answer because that large language model hasn't been trained on the specific details about medical drug interactions, medical related terms, and that entire domain set. So that's where RAG comes in, right? It's imparting that knowledge about that specific field to a large language model so it can get hyper specific. I kind of like always think of it as like a subject matter expert. Like you're making an LLM a subject matter expert in a particular area.
So, and then for that, you have to, I mean, would you have to be constantly retraining your model to be up to speed on everything that's going on around you for RAG to work properly?
It depends, right? It depends on the domain or the knowledge set that you're kind of working with. So, like a good example might be, hey, if you're training an LLM, like whatever type of large language model that is, about like uh, since we're in this medical field, right? Like specific chemistry about like how drugs interact with each other, those rules typically don't change all that frequency. We're not like inventing new forms of chemistry weekly, monthly, even yearly, maybe even on a decade level, right? But if you were to ask an LLM, hey, tell me about like what's currently happening in the AI space, like what's the hot new thing, those large language models probably have a certain cutoff date where their knowledge or their training data has been cut off like 6 months ago or 9 or a year ago, and it's going to be missing the new latest trends in like what's happening in AI. So it might give you some information that seems plausible, but it will be potentially terribly out of date considering how fast everything's moving in the AI space, right?
So what are some ways that people can get around that? I know we talked yesterday actually about some of this, so I'm hoping you'll bring it up here as well. But like, is there a way to bridge the gap between stale data or having to retrain constantly for RAG to work? Is there like a happy medium in there to still be able to get like latest and potentially even near real time results?
Yeah, definitely. So there's a couple of different mechanisms. One is uh, one of the hot topics, especially coming around these days, is MCP, so Model Context Protocol. So that's a great way to augment. It's basically MCP is a server. It's a protocol, but you have an MCP client which is connected or attached to an LLM, which contacts an MCP server or an endpoint that provides some sort of capability to the large language model. So just think of it as a tool, right, that the large language model can use. And behind that MCP server or that endpoint, you can augment it and provide additional capabilities, or what I think is probably going to be the most widely used use case for MCP is providing additional knowledge or real current relevant today happening kind of data sets to these large language models. And then the other mechanism too is something that I've kind of been really interested in is using graph type RAG implementations that augment or play nicely together with graph or vector based RAG implementations, so vector based RAG agents. So those are kind of like the two mechanisms that I see that are really going to be really popular for bringing some of this newer knowledge in quicker without having to do the retrain.
So you've just brought up a few different topics that I want to jump into, but first going back to MCP. So just to clarify, MCP really gives the LLM the ability to understand how to interact with data for a specific tool, correct? So this is like basically laying out the framework of saying, here's how you can talk to, or here are the commands you would use to interact with another system.
Yeah, definitely. So kind of like the way I like to think about MCP is right, like USB, right? So USB hit the computer scene like many decades ago at this point, and USB allowed us to plug in different capabilities and augment our laptop to do different things, right? Whether it's a monitor or a storage device or whatever. So I think of MCP as kind of like a USB bus where you can hook in different capabilities and provide different tools to your large language models so that they can do anything from get or set operations. So like read and obtain more information, augment its data set, or even do set operations like, hey, if this is like an e-commerce thing, go purchase this particular product on an e-commerce site. But the key kind of takeaway for MCP, it's a natural language interface to for an LLM to connect into and access those capabilities, which is super cool.
So basically, 6 months ago, for example, when I would type something into, let's say, Claude AI, it would tell me what I would need to do with some of these systems. With MCP now, rather than it telling me what I need to go do step by step, I can actually integrate those systems with Claude and have it basically just do it for me, correct?
Yeah, and even like an intermediate step between the two, right? They, about what is it, 6 months ago ish, they, large language models and these frameworks came up with function calling. Even then, you had to, in your AI solution, directly import like SDKs and these programming interfaces, where they became very bespoke to the LLM, and they became very tightly knitted with the LLM. So you couldn't like move the functionality somewhere else unless you were doing like a copy paste. Whereas MCP is this separate process, a thing that exists outside the LLM that where it can access that information in those APIs without being exposed to those APIs. Yeah.
Great. So taking that next to the other two words that you used were vector and graph. And I think maybe for a lot of our listeners, they're unfamiliar with what these are. So let's maybe break down vectors, vector embeddings, vector databases, and how all that ties into LLMs with semantic search, so that people can understand. Because I think, we use this every day. If you go to Amazon.com and you type in, running shoes, for example, um, 15 years ago, even 10 years ago, you would only get results of products that had running shoes in the title or in the metadata, right? So how has that transitioned over the years, and how do vectors, vector embeddings change that with the way that AI works here?
Yeah, definitely. So, vector embeddings, it's one of the methodologies or processes for, going back to our, RAG agents. So our retrieval augmented generation agents that become subject matter experts. So that's like the process where you generate vector embeddings. Typically these days, like the default is using a vector database to store this additional domain knowledge into a vector database. So generate the embeddings, put them into a vector database. That vector database becomes like a layer that sits with the LLM, and that's what gives the specialized knowledge to the LLM so that it can, talk about sneakers and the different options and varieties that are available, right? So that's typically when we think of RAG agent, that's what that is that LLM plus that vector database with the domain set vector embeddings to combine and create a, RAG agent that's a subject matter expert. And if we wanted to talk about graph-based RAG is slightly different. And there's a reason why you want to combine both. But graph-based RAG is where you kind of like take all of the uh, domain set, the data set for your particular domain, whether it's sneakers or medical related stuff, and you create structured ontologies in graph world that's basically just structured relationships between two pieces of data, and you put that into a graph database. And what that does is you, when you ask a question about a particular area, whether it's sneakers, you, in a graph based RAG implementation, you retrieve all of the information that's uh, related to sneakers or particular sneakers. Maybe they're Nikes or Jordans or whatever they are. It grabs all of that information and uses that in with your initial query to go sifting through that initial data to find the answer. So it's very different than vector, which is, hey, we've augmented the LLM to know this stuff. Whereas graph-based RAG is like, here's all the data that's associated with your query. The answer lies here. Go sift through this information. So it's very data relational oriented.
Okay. So if we go to the next piece of the discussion, so that kind of wraps up a little bit more around RAG, and we'll probably end up talking about it more this episode. But there's another term that we're hearing pop up, and I'm seeing it at conferences. I'm seeing it online in all the forums. What is agentic AI?
Yeah, so agentic AI it's basically large systems where you have turned over the decision making process to an AI system on how to attack a problem. And usually these days they are combined with, instead of just using simple large language models, they're paired with, these days, with reasoning based large language models. So these are models that take, you know, a minute, 2 minutes plus to churn and think about a particular answer before answering. So it allows the large language model to think about the answer for an extended period of time to get the answer, to get a more precise answer. And in agentic AI, we use these reasoning models to decompose a problem, find out how, just like humans do, decompose a problem, figure out how to attack the problem. These are the steps that are involved in order to arrive at a final answer. And it basically goes through each one of those steps, researches, thinks about the problem, and maybe it might need to refine those steps, right, based on the research that it's finding. And that's kind of the very interesting part about agentic AI. So these are systems that are kind of like non-deterministic in how they get to their answer, because you're literally turning over the decision making process to these AI systems to arrive at that answer.
So, I mean, at that point, I've seen this with several different AI tools that I've used, where I put it into like deep research mode, for example, and I say, give me the outlook or the market sentiment about something, and if you expand what is going on while it's processing, because this could take 5, 10, 20 minutes to run, I'm actually seeing some of that decision making going on, where it says, hey, it pops up a question, and then it answers itself saying, should I check this out? Should I look at this aspect? Okay. And it goes through and it sifts through even more. And I feel like it saved me hundreds of hours of potential work and research over the last few months alone. Or potentially a bunch of interns, looking something up for you. Um, when we have something like agentic AI, is there even a need for RAG or Gen AI, or is everything going to be agentic?
No, I think there's definitely a good use case for having both, right? And it kind of comes down to like how detailed and how specific do you want to get an answer in a particular problem set or domain. And if you were to a lot of these large language models like Llama and Claude, they're trained for like general purpose question and answers. The data sets are very, very large. But if you were to compare the data sets that they were trained on for like medical related stuff compared to just general use, that is probably a far greater subset of its training data. And so there's definitely a good reason to use these RAG agents with hyper specialized data sets saying, I want you to become a subject matter expert in shoes or in medical related topics. So there's definitely going to be a need. And I think you're probably going to see this explode quite a bit. especially right now. There's this big movement to uh, connect multiple agents together to form these agentic systems. And kind of like the architecture of that is, hey, when I kind of reach the limits, when an agent and that says, when I've reached the limits of my knowledge, I want you to go contact a different agent that's advertised its capabilities, that's saying, I know about shoes or I know about medical related stuff. I'm going to go query that agent instead to pick up that information. And when I get the response, the super knowledgeable medical response back, I can use that information and continue on with what I was processing in the original request. And so I think you're going to see a lot of these systems kind of like break apart, creating little subject matter experts that are very knowledgeable in one particular area, but being able to collaborate together when they hit a particular topic they don't really know anything about because they're more general purpose. Let's go ask this other thing that knows way more about it than I do.
So I'm sitting here thinking about this, going, okay, so agentic AI here is very iterative. It's not like I can just type something in and it just does one thing for me. We see this with a lot with coding too, and hearing the term vibe coding, and people will put in a prompt and it starts to build things out. And it's not just a one. And I mean, sometimes they'll say they try and do like a single prompt and one shot it. But at the end of the day, you are tying all these things together. You're tying in MCP, for example. When I was working on a project over the weekend, I was using Cursor, I was using Supabase, I was using the MCP server for that as well, and started off with bolt.new, where I basically said, this is what I want to try and create. And that kind of created a framework for me. And then I pulled that into Cursor and basically said, build out the database side, the schema side, and it started working through all this for me. It would find something didn't work because it would do a test, and then it would fix itself and keep going. My question here is, like, how much trust do we give these right now, and how much trust should we give them? How much should we be kind of like holding back a little bit, or is this just like full throttle right now? Everyone, it's a hot topic and everyone wants to be leading in this. What are your thoughts on that?
Oh my. Yeah, I actually have a ton of opinions on this area. I was speaking at Render ATL, and someone wanted to meet with me before my session and talk about this subject. It's very interesting. I think the vibe coding thing. I think it's actually great because you can empower people who might not know how to code get through an idea that they have, and kind of make its way and see its way through to the final, hey, this is working. I can do what I kind of have it set out to do. However, I think like in the long run, at least for right now, it's kind of very problematic to put those kinds of systems into production without having a real great understanding of like how the different components work and like what it's actually doing under the covers. And a lot of these AI systems haven't been trained on like, what do I do when a bad actor comes in and tries to do certain things. And so I think it's great for like demo and POC kind of purposes, but like in the long run, we still need engineers to like understand how these components, these interactions between the components work, and to like really think about like what's happening under the covers to understand security and like how do I fend off bad actors and that kind of a thing. And a lot of it, if we want to go into like deep dive into the technical aspects of it, a lot of it is because of the context window, right? Like especially with small projects, not a big deal. But when you get to more real world useful products, there's only so much information you can put into context windows, even though like Google Gemini has, quote unquote, like a 2 million token context window. You can't fit these massive storage code for storage systems or DevOps related code into these context windows, have it expected to understand everything that's going on with the system, and then producing code and updating, whether it's patches, security releases, or whatever, to update the code to reflect that. And at least for the time being, you definitely are going to need people to understand those larger higher level concepts, understand like security, and even especially now, kind of like where I was talking with that person at Render ATL, keep LLMs honest with the code that they produce. So we need to like lean into uh, unit tests and integration tests and those types of validation, so that we can keep these LLMs and these agentic AI systems honest, and what they're producing is actually what we want, right?
I think one of the struggles that I have sometimes when I'm trying something new like that with vibe coding is the LLMs come off being so confident in what they're saying. And I'm like, sure, this sounds good. Copy, paste, let's run this, And then something breaks and I say, hey, like this is broken. And it's like, oh, you're right. And then it will tweak itself and try to fix it. And I find that it's really sharp at the beginning of a project, right? The context window is pretty small. You're probably at, anywhere between a couple thousand, couple tens of thousands of tokens. But once you start growing this and it's a project with, 30, 40 files and the complexity increases, I start to see it that it's losing some of that context. It's like, I told you about this. You actually helped me write the code for this piece here, but you just completely messed up interacting with it. So definitely see some of that. And I think my feelings the same. Like I would not be running that in production quite yet.
Yeah.
Depending, like if it has access to systems, if you're telling it that it can control firewall ports and other things, it's I don't know that my confidence is quite there yet.
Yeah, I had one mentor, like one of his famous things that he always would tell me, way back in the day was like, it's okay to not know. Like I'm a lifelong learner. I love learning about new things that I don't know about, whether it's in medical or this, that, or the other. But like one of the biggest mistakes that you can make is like being confidently incorrect, because you're not challenging your own assumptions, and like you're not challenging yourself to make sure that what you built is actually what you set out to do. And like you're saying, like those LLMs, when they're confidently incorrect, it can be disastrous for sure.
Especially when you're trying to learn the technologies, right? Like I'm sitting here and I'm reading through the code. I'm like, okay, this makes sense, to the extent that I understand it. But all of a sudden it left out anything around security because it just wanted to make it work. So all of a sudden I'm not using row level security in my database, and potentially a bad actor or another tenant could come in and read that data, all because the LM was so confident that it gave me what I needed when at first I even said, make sure this is secure, right? So I think that it's great. It's helped me learn to code so much faster than I could have done, even a couple of years ago, just cruising through Stack Overflow looking for answers. Now I'm learning full concepts, or I get to something and it tells me something I don't quite understand it, and so then I start chatting with it, right? I say, help me understand this. So I think it's a great learning tool. On top of productivity, but we're still not quite where we need to be, I think.
Yeah, and I think it's an amazing learning tool, and it's especially these days, at least for the past 9 months, it's the first place I go to. Like you said, I use deep research. Hey, go research this topic for me. Save me 2 days of pulling code examples together. It's definitely not going to be 100% correct. It might even be outdated code, but it's a good place to start to like break down the concepts, and then you as an engineer go figure out like, oh, this is what it's trying to do, and let me put all those those best practices and those things around there, like security and things we need to worry about in the real world, and apply it to like what the research that it's given me, right?
Yeah, exactly. So let's jump topics here really quick. You are presenting at a lot of conferences. I've seen your conference list. I've seen some of the sessions that you've done that have been posted on YouTube. You're everywhere. You're deep into AI and ML. What are some of the hottest things that you're seeing either currently or that are kind of on the horizon that would be interesting for our listeners?
Yeah, definitely. So I had my last talk was at Render ATL, and it was literally, the title of the talk was like just-in-time user interfaces and user experiences. And I kind of like, the talk was probably not what people were expecting, but I think it was very well received. It was kind of like making the case of what I think like user interfaces were going to be. and it was kind of like laying out the case of like what's happening, and I was literally pulling out news articles of like what's happening today. So as an example, like OpenAI is pioneering, made large language models and chatbots super accessible to everyone. And it's kind of very interesting to see like some of the things that they're looking at. And so it was kind of breaking down the things that OpenAI was doing. So as an example, several releases ago, like 6+ months ago, they started to really put in effort to making sure that all of your previous chat history was referenceable so that you can use it going forward in all of your future chat uh, conversations with ChatGPT. And that in turn now makes the AI system understand you a lot better. And OpenAI also purchased the company that Johnny Ive had called IO, which now there's a legal trouble about the name, but the purchase is still there, where they want to introduce a hardware device to kind of effectively, and they've kind of come out and said it, to effectively have us use our phones less. And the idea is that they're kind of trying to make this device so that it's more context aware and more aware about you as an individual, so that instead of having to search for things, it will asynchronously ping you and say, hey, you might be interested in purchasing these concert tickets, which was actually the demo that I presented, just based on searches that I was doing on LCD Sound System, which is my favorite group, by the way. But so I think that's a lot of the cool, interesting things that are kind of happening, where things are going to get more contextual, more focused. And like I kind of said at the talk, they're super ahead and they're super advanced in where they're at because they're leading, one of the leaders in the AI space. But now we, as kind of like small, medium businesses, because that was like a large part of the group that was there, we have those tools and we now have those capabilities and we have the knowledge now to do that. So how do we make it so we lower the barrier of entry for our users to get to where they want, like the answers, the tickets, whatever it is, quicker? And I think that's going to be kind of the future of a lot of the stuff we're going to see. More data science, the short answer on that.
That's fantastic. Well, hey, thank you again for coming. We've talked about Gen AI, we've talked about RAG, we talked about vectors and graph databases, MCP, Agentic AI. This has been a full 30 minutes. So really appreciate you coming along. Where can people find you if they want to learn more from you?
Yeah, for sure. Yeah, all my socials are David VonThenen. So LinkedIn, GitHub, all my socials, David VonThenen, one word, no spaces. You can reach me there, YouTube, all the fun stuff. Yeah, looking forward to chatting more about everything AI and ML.
Awesome. Thank you very much. And we'll talk to you all next episode. See ya.
Bye.